To everyone who's joined us, welcome so much for our fourth. Yeah, time flies. This is our fourth webinar this year. And today we are honored, as Miriam has indicated, to be joined by Larry Ludwig. Larry Ludwig wears many hats, and one of the hats is that he works at Schaeffer Manufacturing. Basically, they deal with specialized lubricants. He's a renowned trainer, even with the Society of Tribologists engineers, lubricants engineers, where he's worked with them several years. I was amazed to hear that he's been at Schaeffer. Is it Schaeffer or Schaeffer for the last
Schaeffer.
48 years? Schaeffer, the last
Yes.
48 years. So he has quite a wealth of knowledge, and we are happy to have you around this afternoon or morning, wherever we are coming from, to listen to some various items that we are going to basically discuss or have a conversation. So today we will be talking quite a bit of a mix. We want to look about lubricants and the OEM nexus, how the OEM and the lubricant manufacturer work together in terms of developing the lubricant. We look at a bit on some gear, lubrication, and lastly, we talk about greases. And I think these are all areas that we are trying to tap from Larry. And so, Larry, I want to give you an opportunity to first introduce yourself. I think I might not have made justice to your introduction. Maybe you can introduce yourself.
Okay. I'm Larry Ludwig, Chief Chemist and Technical Director for Schaeffer Manufacturing. I've been with Schaeffer ever since I came out of university for 48 years. I have a Bachelor's of Science in Chemistry from St. Louis University, and been heavily involved in this industry, particularly with STLE, Society of Tribologists and Lubrication Engineers, and NLGI, which is the National Lubrication Grease Institute. I sit on various committees, particularly the Education Committee in STLE, run the Gears 101 education course. For NLGI, I am currently the co-chairman of our food grade lubricants working group, vice chairman, formerly co-chairman of the bio-based working group. And I have my certified lubrication specialist, my OMA oil maintenance analyst 1, and certified metalworking fluid specialist from STLE. My goal is not only do I help our company formulate lubricants, handle some regulatory, particularly European, in terms of the REACH and some of our own US EPA regulations. My goal mainly is to bring up newer chemists, to educate them, teach our sales staff and our customers in aspects of lubrication. And I worked.
Awesome. I think that's
yes.
Yeah.
And I worked a little bit closely with some original equipment manufacturers too.
Wow. I think that's a wealth of experience and I think knowledge. And I think maybe we can start from there because you've worked with quite a number of committees and there is that interface with the OEMs. Maybe you can highlight why do we sometimes have recommendations that we have to use OEM lubricants, OEM recommended lubricants in our machines or equipment, and then as a manufacturer, how do you come up, how are you able to develop a lubricant or a grease that is as OEM recommended?
Okay. Basically, most of the OEMs will have a basic specification for a grease or a particular oil-based lubricant. They will say use an NLGI #2 extreme pressure grease. If a warranty situation occurs, there they may have a set of lubricants that they have already approved, and you have to use those in the warranty period. You have others that will give a list of lubricants that they know has worked in their equipment, but they'll say you either use these or an equivalent. It depends upon the particular OEM and how they have structured it. If they have a formal approval, you then have to contact the OEM. Now, sometimes you can do it through the additive supplier that you are using. You tell them, I'm looking for a lubricant that will provide performance and approval, say in a ZF TEML 06A specification. They will go through their data files, suggest to you that you can use this additive at this particular treatment rate. Once you know that, you can start formulating blends of the product in different various base oils. You should obtain also a copy from the OEM of the particular specification, so you know what the targets are for performance. They may have some guidelines on, say, it has to have a certain 4-ball rating, certain viscosity grade, certain pour point, and so forth. Once you obtain those, you make your blends. You put in the additive package. In some cases, myself, I would go to several different additive suppliers and ask them for a particular additive system that would meet that particular specification, blend up the samples. Once blended, then using an independent lab and also in-house facilities or test equipment, run the test. Would also have our additive supplier help us do some of the testing, because they have some of the testing already in their particular laboratories. Once that is all done, if I'm seeking an OEM approval, I will then choose the formulation that has given the best results and submit that to particular OEM for evaluation. They will either look at the test results, or they may ask for a sample to run their own test results in their own laboratory to confirm the results. Once they sign off on that particular lubricant formulation, then it is time to start basically sharpening the pencil and looking at your raw material costs, looking at availability, which you've been doing all along, and also the supply chain aspects of it, and determine what you could sell the particular lubricant for, and introduce it into the market.
Wow. So apart from warranty, because during warranty, most of the times you're supposed to use OEM recommended lubricants. Are there other instances that you may be forced to use OEM recommended lubricants?
It's usually during warranty or an extended warranty, but in a lot of cases, and some of it is structured based upon the particular laws that are prevalent in the particular country. In the U.S., we have what's known as the Moss-Magnuson Act, where unless they have particular specification that you have to meet and specific tests, you're allowed to use any choice of lubricant you want, whether it's under warranty or is suitable for use. For instance, most in engine oils, most original equipment manufacturers will say you must use a oil that is an API license, CJ4, CK4 if it's a diesel engine oil. And as long as you have that license, or you have the backing of your additive supplier, if you chose not to license the oil, because the API licensing is a voluntary choice. If you can prove through your additive supplier that it meets that particular specification, has undergone all of the particular engine sequence test, you can go ahead and use that particular oil as long as it meets or exceeds that particular specification.
Thanks. And I think it's important now that we know we may be driven so much to use OEMs lubricants when the product is new, the equipment is new, and if you don't use it, then you may lose or forfeit your warranty. I want to take you to another line, per se, especially in the African context.
Okay.
In Africa, we more or less don't formulate our lubricants per se. Most of the players will use lubricants that are already formulated, maybe by some big manufacturers. How do we link or align ourselves with the OEM requirements? Per se, if I am going to buy a product which is not from the big multinationals, for example, I don't know how we could align ourselves as small players who are basically getting products and using some formulations. Are these formulations acceptable to the OEMs?
They can be. Depending upon how it's structured. If you're blending a particular lubricant to a specification, it's always important to first look at the specification. They may have in there, let's say, a hydraulic fluid that has to meet DIN 51524 Part 2. which is for an anti-wear hydraulic fluid. You need to do some research. I always suggest that you obtain that specification. You can purchase these. Yes, they can be a little bit expensive. It's not unusual to purchase a PDF from certain sources, and it could be in the $200 to $300 US dollar range. But it's always helpful to have that specification on hand. Look at the particular performance specifications. Contacting the OEM and asking if they have additional specifications. Some cases, just going in and looking at the operator's manuals for a particular piece of equipment they may make. I'll give a general recommendation. Once you have those, you can then formulate your lubricants the same way, working through your additive suppliers. You could choose mostly whatever base oils you want. It's very rare where particular OEM will say you must use a group only group 1, group 2, group 3, group 4, or some type of particular synthetic. You do have freedom in formulating that way for the majority of OEM specifications. You may also, if you're not blending it yourself, say you're a distributor, you go back to whoever you're distributing for, whether it's ExxonMobil, Total, as prime examples. You ask them, do they have a lubricant that meets particular specification for this piece of equipment? They will go through their data files, and they'll say, yes, we have this particular hydraulic fluid. And you would ask them for the product data sheet and the list on the product data sheet of the OEM or the DIN, the ISO, API, ASTMs, whichever specifications that it meets. And the majority of lubricant manufacturers will have those listed and will can back it up.
What is the cost like that kind of thing in terms of, for a company, for example, a local company in Africa, what could be the cost implications? And then looking at the various lubricants, because there are very many lubricants that you're dealing with. You may be dealing with 7, 8 types of engine oils. And that's maybe petrol only. Then you go diesel. Do you have to do all those tests, all those formulations, all those field tests and all that? Yeah. Maybe you can give us in a nutshell, just 1 minute. What do you think about that?
Okay. As far as the engine oils go, you would work with your additive supplier. They will provide you, let's say, a CK4 formulation or API SN plus gasoline engine oil formulation. They will have run a set of engine sequence tests in particular base oil combinations with engine oils is primarily Group 2 type base oils. They will also offer guidance that, according to the API 1509 bulletin, that you could substitute certain base oils, say if you wanted to put in a PAL Group 4 in place of a Group 3, you can add a certain percentage, and you would have a base oil read across that you could use, and you don't have to run all the particular test again in the formulation. Excuse me. You then would take that formulation and you basically submit it to API on their secure website, provide all the test data that you have received from your additive supplier, and some of the particular engine sequence test stand numbers that it was ran in, and you receive your license. As long as you have that license, the OEM will accept you. And you could then use any brand you want to. They will not particularly say, you have to use Total XYZ engine oil.
Thanks. I think we can now switch to something about gears.
Yes.
And gear lubrication. I have two questions. One question will be, we don't have a lot of issues with the automotive gearboxes. Yeah, I don't know. But when we talk about industrial, then we have issues. I don't know. Maybe you could highlight that.
Yes, a lot of the issues that you find with industrial gearing boil down to either lack of maintenance, contamination of the lubricant, or in some cases, trying to use one particular viscosity grade or one particular lubricant for everything, just to try to reduce cost. All those can actually result in a failure, particularly trying to consolidate gear lubricants. You may have some industrial gear drives that do not require the use of a extreme pressure gear oil, particularly if they have some type of backstop mechanism in the gearbox. Backstop is basically a braking mechanism. You find those on conveyors that are inclined. That backstop is there to, when you want to stop the conveyor from moving, you lock that braking mechanism so the load the conveyor itself does not roll back towards you. You put an extreme pressure gear oil in a gear drive that has an internal backstop, that backstop will no longer work. And the next thing you know, you're standing at the bottom of the conveyor, and you're seeing the load of rock coming towards you. Some cases, you're trying to use the one viscosity grade for everything, say an ISO 220. In a gear drive, that may call for an ISO 150 or an ISO 460. Viscosity is always king. Always you should use the viscosity grade that is specified by the OEM. If you use the wrong viscosity grade, you will not have the proper lubrication and the proper film thickness, especially in gearing. You can overheat the gear drive. Those increased operating temperatures will then start oxidizing the lubricant. And once oxidation starts taking place, that lubricant will start breaking down, leaving deposits, and just destroying itself. Contamination. Gear drives, regardless of what part of the world you are in, will pick up moisture, will pick up contaminants, airborne particles. You need to protect the gear drive from those. Not only properly storing your lubricants to keep them from contamination, but making dedicated to checking filters if there are filtration systems on the gearbox. If any breathers are on a gearbox, make sure you have some type of filtration on the gearbox itself, especially a desiccant type filter. If you're in a very humid environment or in an environment where it would rain a lot or you have moisture pouring onto the gearbox, the desiccant filter will absorb that particular moisture and keep out the water. If any contaminants get in there, particularly water, have the ability to be able to drain off any of the free water once it's demulsified out of the gear oil. Periodically take samples at least once a month, and in some cases do routine analysis, and then I suggest every 3 to 6 months doing more in-depth analysis where you're looking at barographic analysis to look at larger wear particles. Barographic analysis, you can determine where those wear particles are. Set up a PM schedule where you can actually inspect the gears and look at the gearing. Gear inspection, I will tell you, it can be a very dirty job. Expect to get dirty, to get covered in stuff, but it is very important to, on a yearly basis, to inspect the gearing for wear. Take operating temperatures by taking operating temperatures across the housing of the gear or the reservoir of the gear. You can determine, in some cases, maybe misalignment is occurring. If you see roughly a 5 C difference between one area shooting across the housing to the other area, odds are you may have some misalignment taking place. that misalignment gets too severe, you can break a gear tooth. And, do these periodically and record the results. It's very important.
Larry, you've talked about gear inspection. Most of us just know gear inspection for the big gears, like the gas gears, the mining, in the cement industry. Do we do the same kind of inspection even to smaller gearboxes in the industry?
It is similar. With girth gears, you also look at the particular application system you use, such as centralized lube system, where you're spraying that on it. But you still, when you're doing gear inspections, you are looking for scoring. You are looking for any pitting. You can take with a smaller gear set, you can actually clean off the gear, take the gear, and with a paintbrush, you have a Dicam paste that you could use with dye, and you can run the gear set under no load or load, say at 50% load, 100% load, 10% load, and you could put down tape on the gearing that you could give you what the gear profile looks like and compare those to known standard charts that this is showing misalignment, this is showing such and such. And you could keep those and track those. You also at that time do oil analysis. Pull the samples. If you see failures starting to occur, then go back and look for any root causes. Work with it. And as a lubricant supplier, the lubricant manufacturer, their field people will help can help in those gear inspections and work with the customer as a team. They'll work with their reliability engineers.
Thanks. I will tell the audience you could type your question in the Q&A section. Towards the end, the tail end of the session, we'll be able to have the questions responded to by Larry. Larry, do you have maybe some images you should show us about some inspection that you've done? Maybe something.
Yes.
I would be keen to see for this. Is it for both the big gears and the gas gears and
it would
small
be
ones?
more or less for the both gears.
Okay. Okay.
Let's see here. Get my share. Okay. And as I said, you take a root cause analysis approach and you use a team approach and always have with you some type of inspection form. You can make it up yourself, or they may be an inspection form that the particular customer may have, and use those. And you always want to record any type of failures if they've occurred. Interview the operators. Has anything changed? Record the evidence by writing it down. get as much service history, maintenance records as possible, any drawings or copies of drawings, and have with you some type of image. I mean, not image, some type of camera, whether it's your cell phone, iPad, even a digital camera. Take pictures. Visually, you want to walk around the whole gear drive. Take a look at it in operation. Open up inspection ports and look at the gears as they're moving. In open gearing, you can actually set the taking a strobe light, setting the strobe light to the pinion speed, and you can see how the gear lubricant film is forming. You can also do the same thing with a smaller gear drive. Take temperature methods, whether they're infrared, RTD probe, thermographic. Use vibration analysis if that is available. Look at filters, inspect them, any magnetic debris collectors. They'll have large metal particles, and you can decide if you need to go further. I always measure the gear backlash and any shaft in play. Backlash is very important because without the proper backlash settings, that lubricant cannot get in between the gear teeth. Record any tooth contact patterns, whether with a dye penetrant. Do the lubricant analysis and document everything. These are basically tools I can carry with me. You don't need to have all of them at a particular gear inspection. One of the most important ones I always have if I go out in the field to look at a piece of gearing or find out a recommendation is a wire brush, because I will look for the gear plate on the gear drive. The gear plate gives you pertinent information on some of the specifications of the gear drive, but it also will tell you what type of lubricant to use. And then I will check to see is the proper lubricant being used. Of course, flashlight, you always want to have the and wear the proper personal protective equipment, be visible, and always follow the safety rules that the customer has. And particularly, don't automatically open up an inspection port and stick your hands down in there. Unfortunately, you wind up in the gearbox and part of the gear mesh. Visual inspections. You do an actual walk around. And here's an example. Look for any signs of overheating, corrosion, contamination, oil leaks, damage. Note those if you see them. Look for any movement. I mean, if you start seeing cracking paint, any fretting corrosion on fasteners or bolts, vibrations occurring. Look at the breathers. Check any seals, especially on the shafts. Check if all the bolts are tight and coverly sealed. And only a qualified personnel should open the gear, the inspection ports, and you got to use proper lockout and tag out procedures. Those are for your own safety and the safety of the people that are around you. And you look at the condition of the gears and the bearings and examine the gears with by a magnetic particle inspection. Look for any signs of overheating. The gearbox could be literally smoking from either the shafts or the seals or the breathers. You could see discolored or burnt paint on the housing. Colors can be tempered on unpainted surfaces. You might see some bluing of the metal surface. Look at the sight glasses for low oil level, any foaming, any dark color oil, any foul or pungent or acrid smell, water in a sight glass or any sludge, and metal chips on any magnetic plugs, detectors, or filters. And you look for visible signs of overheating. You record the operating temperatures. And you take them at 0% load, 50%, and 100% load. Shoot across the housing, and if you have the 5 degree C difference, there's misalignment probably occurring. You just want to inspect everything. Look for any, use your hearing, look for any unusual gearbox sounds or vibration. And take oil samples. As I said, look at the backlash and the shaft in-play. Measure those by mounting a dowel indicator to the pinion tooth. That's similar to the pinion tooth valve. Block the gear, prevents rotation, and rock that pinion through the backlash and measure it. Basically, kind of the same way with the shaft in-play. Take tooth contact patterns. These can disclose gear mesh alignment, and they can suggest what needs to be done during the commissioning of a gear drive. And they should be regularly repeated. It should also be done before assembling a gear drive for repair. And do contact pattern tests at load and unload, and record and document and photograph the gear's contact patterns. First, thoroughly clean and paint the teeth of one gear, the SARC marking compound, the Dicam compound. You roll those teeth through the mesh so that compound transfers to the unpainted gear. Then you turn the pinion by hand while applying a light load to the gear shaft by your hand or a brake. And you lift the pattern from the gear with Scotch tape and mount on paper to form a permanent record. And here's an example of what you would do. That's it. This image shows a no contact pattern transferred to unpainted gear. And this image shows a different sector of the unpainted gear. It's revealed in the photo. Once you put down the tape, you have a pattern, your contact pattern, and you mark it and identify it. You can take those contact patterns and compare them against some published results that you can have. Like say in A, you have a load carrying pattern on the gear with a wobbling pinion. You know that pinion's probably wobbling, and that could eventually cause excessive wear or scoring.
Thank you very much,
You're welcome.
Larry. I think because of time, I would want to welcome Miriam. If you have some questions that Larry could answer.
Thank you, James. Larry, we have two questions for you.
Okay.
One is about gear failure. Someone is asking, when a gear fails, does the identified failure influence the choice of oil to use?
It can, depending upon if the gear failure could be attributed to using the wrong type of gear lubricant. Say the too heavy or too light of a viscosity. Using a non-EP type gear oil in a heavily loaded gear drive. That is, well, when looking at gearing failures, one of the first questions I always ask is, what particular gear lubricant did you use? And I would double check the original equipment manufacturer's recommendations. I would also then pull samples if they are using the right type of gear lubricant and have those analyzed for any contamination or lubricant breakdown. You can get into a little bit of a gray area. It's always to combine not only lubricant analysis, find out what is being used, but also to actually go in and inspect the gears and look at service records too.
Thank you for that. The last question is, how significant is the role of lubrication in preventing gear failure? And are there specific lubricant properties or formulations that enhance gear life under extreme conditions?
It is very important. The most important property of any lubricant is viscosity. Using the proper viscosity. Use of the proper viscosity will provide the proper hydrodynamic and elastohydrodynamic film that is needed for gear operations to prevent excessive wear. Having the proper additive system, heavily loaded gearing. Once it goes into boundary lubrication, you need to use an extreme pressure type gear oil. That will help prevent or mitigate wearing. You will never totally eliminate wear. You can extend the life of a gear drive by using the proper type of a lubricant. But you have to couple that with doing oil analysis. That is extremely important. You do all that. You take care of your equipment. You shoot temperatures. You inspect the gears. That gear drive can last for many, many years. I'm not going to say that a failure will not occur. There can be some mitigating circumstance where it may happen. But use of the proper lubricant, storing the lubricants properly, taking care of the equipment will extend and help mitigate, or in some cases, even prevent gear failure.
Thank you for that elaborate answer, Larry. Those are all the questions we have from this end, James. You could take it up and maybe wrap it up.
Yeah. Thanks, Larry and Miriam. I think there's something, but I'll maybe link you up with the person who has asked the question on those failures, on how maybe somebody can identify the different gear failure types and how they could link you to know, is it a lubricant related problem? You will be able to see maybe because it's scuffing or micropitting, then you could link it with a certain kind of root cause, or a cause.
Yes, you can. You have there are published wear patterns and causes of those that you can look at, but also too, you need to gather the information on the history, the service, the particular gear drive, what they are using. And a lot of cases too, you'll find that in some gearing applications, they're actually using the gear drive in situations where it's over its rated loads. And that can be a contributing factor. You wind up, it's not unusual sometimes. You may need a specific type of gear drive for a particular application. You have it ordered, and I've seen then the accounting firm or the accountants that are in your organization, or whoever makes some of the financial decisions, say, I can use this gearbox a lot cheaper, and it's not rated for the loads and a particular application, and it winds up costing your operation money and downtime and lost production.
Great. I think we can wrap it up. We want to thank you very, very much, Larry. I know there is still one area we have to really do some justice, and I believe it's something that's going to be really, it's really needed in Africa, and not only in Africa, globally. That's concerning food grade lubricants.
Yes.
And also greases, yeah. So
yes.
we will address that, and I think we'll call you soon to
Okay,
another
that will be
webinar
fine.
where we'll be addressing that. Basically, we'll just address greases and maybe with a bias on food grade lubricants, food grade
Okay.
greases. Yeah,
That will be good.
awesome. So for the audience, we want to thank you so much for tuning in. One, I think it's so important to note that as Lubezine, we've been able to start posting these recordings on our YouTube channel, and we would want to indulge you to our YouTube channel, and you could even subscribe so that you can be seeing what we have there. I want just to see if I can share the YouTube channel. Yeah, this is our YouTube channel. This was the last recording that we had last time. So feel free. We'll be able to have the other one. Of course, this one also recorded and put up here. Come in and subscribe, as well as watch all the recordings. So for all the people who had registered, we'll be able to share the recordings, the link of the YouTube channel. Yeah, it's already been posted on the chat. So we'll be able to share this via email, and you can be able to see the whole of the recording, so that you can even have a reference to your case. There are still some few questions that have come in, but I don't know if we'll be able to answer them. But Ludwig, allow us, we can share them with you on your email.
Yes, that
and
would
then
be
you
fine.
could respond even to the person via email or to us. Then we can push them to you, to
Yes,
them.
that would be good.
So for now, thanks so much, Larry, for your time, for your insights, and the sacrifice. And we also want to thank them that were able to join the audience, and also them that are going to be listening afterwards. We just want to thank the team that was able to bring this together. That's Miriam, Peace, Patience, who were able to bring this together. Thanks so much, and I pray that we all have a nice afternoon and a nice morning, depending on where we are. God bless you, and goodbye.
Bye. And thank you very much for having me, and have all of you have a pleasant day.
Welcome so much.
Bye.
Bye.